Hi everyone, it's Miss Costa here, and in this video we're going to go through the GCSE EDEXCEL Foundation Paper 1 for June 2017. Okay, so in this question I'm being asked to write down the value of 2 to the power 4. Now when anything is to the power of something, this is called like the indice or the power, and it means that my base, the big number, is multiplied by itself however many times this number is. So it's 2 to the power 4, which means 2 multiplied by itself 4 times. So that would be 2 times 2 times 2. And they're being asked to work out the value of it, so I actually have to work this out. So 2 times 2 is 4, times by 2 again is 8, times by 2 again is 16. So therefore 2 to the power 4 would be 16. Now for the next question, I'm asked to write 7.26451 correct to 3 decimal places. So what I do is I write out my number and then I circle the digit that is 3 decimal places after the decimal point. So that's 1, 2, 3. So I circle this number and then I look to the number next to it and I think to myself, if the number is 5 or more, I'm going to round up. If it's 4 or less, I round down. So that's a 5, which means that I'm going to round up, and what I do is I add 1 to my circled digit. So that would become 7.265. I keep everything else the same. I'm just interested in rounding the circled digit. So to 3 decimal places, that would be 7.265. Now for the next question, I'm being asked to simplify. So in algebra, we don't like to write multiplications. So for example, 7e means 7 times by e. So when a number and a letter are next to each other, it's given, it's implied that they are being multiplied. So when it says simplify, it just means bring everything together. So first I'm going to look at the numbers, and I've got 7 here is being multiplied by 8. So 7 times 8, I know, is 56. And then e times by f, so I could rewrite it as 56 times by e times by f. And with algebra, I know that whenever anything is being multiplied, I can just write it, bunch it together. So that would become 56 EF, because there's an implied multiplication sign in between them. So whenever a letter or a number or 2 letters are next to each other, it means they're being multiplied. So that would be 56 EF. Now for the next question, I'm being asked to solve. So solve means find the value of. So essentially, you have a variable, so letters like X, Y, Z, things like that. So you want to work out the value of X. And in order to do that, you need to get it in the form X equals. So X by itself on one side. So if we have a look at what the algebra is doing, over here, X is being, this is a fraction, X over 5. This divisor in the fraction means divide. So I could think to myself, okay, X is being divided by 5. So X divided by 5 is 2.5. I've just written it as a decimal just to make life a little bit simpler. Now, something is being divided by 5. So if I said to you, like, I don't know, here I've got a big chocolate bar, giant chocolate bar, and it's worth 10 kilograms, and then I split it between 5 people. What am I doing when I'm dividing? So I'm going 1, 2, 3, 4, 5. 10 divided by 5, each individual part would just be 2 kilograms. So when I'm dividing, I'm splitting it. So in order to solve an equation, we need to do the inverse, and the inverse of division is multiplication. Inverse of subtraction is addition, and so forth, and they go backwards and forwards. So the inverse of dividing by 5 is multiplying by 5. And the reason I do the inverse is because anything divided by 5, like 10 divided by 5 is 2, but then 2 times 5 takes me back to 10. So I do the inverse operation so that it cancels this out. And I need to keep my equations balanced. So I'd be left with X equals 2.5 times 5, and this is a non-calculator paper, so there's a few ways we could do this. I would probably just do the lattice method, so turn it into 25 times by 5. So 25 times by 5, and I did one too many things. So 25 times by 5, I do 5 times 5, which is 25, 2 times 5, which is 10, and then I just go along the diagonals and count what's in them. So over here I've got 5, over here I've got 2, over here I've got 1. So I know that 25 times 5 is 125, and therefore 2.5 times 5 is going to be 12.5, because when you're multiplying decimals, whatever you have in your calculation, so you've got 1 digit after the decimal point in your calculation, and you're going to have 1 digit after the decimal point in your answer too. So x would be 12.5. But there's a lot of skills that are coming at play over here. The key thing is you just know that you need to multiply both sides by 5, and then if multiplication is an issue, let me know and we can go through multiplication in a separate video. So for the next question, I'm being asked to write 4 over 5 as a percentage. So there's a few ways to do this. Because this is a non-calculator paper, the best way probably would be to just make it an equivalent fraction out of 100, because what a percentage means, percent means out of 100. So anything expressed as a fraction out of 100 is a percentage. So I can say to myself, okay, 5 times by what makes 100? 5 times by 20 would get me to 100. So I need to do the same to the numerator as well. 4 times by 20 is 80. And 80 over 100, anything over 100 tells you what it is as a percent. So that would be 80%. If you're not very good at spotting how things multiply, you could do it the other way, which is do 4 divided by 5. So 4 divided by 5 over here. How many times does 5 go into 4? 0. How many times does remainder 4? How many times does 5 go into 40? 8. So 4 divided by 5 is 0.8 as a decimal, and to turn a decimal into a percentage, we multiply by 100. So I'd get the same thing, just depends which way you find easier. So 4/5 as a percentage is 80%. Now for the next question, I need to work out 60% of 70. So as it's non-calculated, the best way to start with these is to work out 10%. And the shortcut, so to work out 10%, the shortcut is to just divide by 10. Okay, so to find 10% of anything, just divide by 10. So 10% of 70 would be 70 divided by 10, which is 7. Okay, so I know that 10% of 70 is 7, and I need to work out 60%. So what do I multiply 10% by to get to 60%? I multiply it by 6. So I do exactly the same to the other side, and 7 times 6 is 42. So 60% of 70 would be 42. So over here I've got a probability scale. So a probability scale is literally just saying from no chance to 100% chance to definite, what's the probability, what's the chance that something will happen. So semi-spin's a fair 4-sided spinner, and the fact that it's fair is important. It means that everything has an equal chance of landing. So on the probability scale, mark with a cross the probability that the spinner will land on B. So there's 1, 2 sides that would be B. So the probability of the spinner landing on B, remember probability you always write out of your total. So how many options do you have in total? You've got 1, 2, 3, 4 sides in total. So probability would be out of 4. And how many of those options are B? 1, 2. So the probability of it landing on B is 2 over 4. And what I can do is just simplify that into its simplest form. So 2 over 4, if I divided everything by 2, so 2 divided by 2 is 1, 4 divided by 2 is 2. So the probability would simplify to 1/2. So I could just mark that over here. Now it says on the probability scale, mark with a cross the probability that the spinner will land on F. Well, there are no F's, so that would be 0 out of 4. So I'd mark my cross over here. Next, we've got Fahima, who buys 2 packets of bread rolls costing £1.50 for each packet, 1 bottle of ketchup costing, so let's write it, so bread equals £1.50, and there's 2 of those packets. Then the ketchup costs £1.60, and she just gets 1 of them. And then 3 packets of sausages, which we don't know the cost of yet. So she pays with a £10 note and gets 30 pence change. She works out that one packet of sausages costs £2.30. Is Fahima right? So first of all, let's work out what we can. So bread is £1.50 times 2. So £1.50 times 2 is going to be £3. £1.60 is the cost of the ketchup. So let's add up the cost of what she's paid for so far. So £3 plus £1.60 is £4.60. So she spent £4.60 so far. Now she pays with a £10 note and she gets 30 pence pack. So in total, she has spent £9.70 is spent. Okay, so she spent £9.70 in total, and the cost of her ketchup and bread rolls is £4.60. So we know that if she spent £9.70 in total, we could figure out what the difference is between how much she spent in total and what we know that she's already spent on bread and ketchup. So if we do £9.70, take away £4.60, we can figure out what the difference is. So 0 take 0 is 0, 7 take 6 is 1, and 9 take 4 is 5. So we know that she spent £5.10 on 3 packets of sausages. So to work out what 1 packet of sausages would be, we'd need to divide by 3. So £5.10 divided by 3. How many 3's go into 5? Once, remainder 2. How many 3's go into 21? 7. How many 3's go into 0? 0. So 1 packet of sausages must equal £1.70. So is Fahima right? No, she is incorrect, as they cost £1.70. Okay, next we've got multiplying fractions. So when we multiply fractions, all we do is we multiply the numerators together and the denominators together. So we've got 5 over 8 times by 3 over 4. And 5 times 3 is 15. 8 times 4. And also a little trick with the non-calculator paper. You can do the halving and the doubling and halving method. So 8 times 4, if you're like, oh, I've forgotten what 8 times 4 is, you could halve one and double the other. So let's double this to 16, and that would become 16 times 2. It might be a little bit easier. Multiplying by 2 is sometimes easier than doing the times tables. So 8 times 4 is 32, 16 times 2 is 32 as well. If you wanted to, you could double again, so you'd end up with 32 times by 1. As long as you double one side and you halve the other, the answer is going to be exactly the same value. So that would give me 15 over 32. And that's all I do to multiply fractions. You just multiply the numerators together and then you multiply the denominators together. Then we've got subtracting fractions, which is a little bit harder. So in order to add or subtract fractions, they need to have the same denominator. And this is a really key important point. So they need to have the same denominator. So how do we get the same denominator? Well, what we do is we look for the lowest common multiple, the first number that appears in both of the numbers times tables. So we look at the denominator, and if you're not confident with your denominators or if they're slightly higher numbers, what you want to do is just write out the times tables of each of them, just the first few, and then think to yourself, what is the first number that appears in both of these numbers times tables? And that would be 12. So your new denominator is going to be 12. And then you think to yourself, okay, what have I multiplied 3 by? 3 times by what gets me to 12? 3 times by 4 gets me to 12. So what I do is I multiply the numerator by 4 as well. So I times this by 4 and I times this by 4, because to keep fractions equivalent, you need to multiply the numerator and the denominator by the same thing. Like 2/3 is the same as 4/6 is the same as 8/12, okay, because they stay in the same proportion. So for example, this is 2/3, and if it was to be 4/6, then 1, 2, 3, 4 out of 6. It's the same proportion, it's the same amount, it's just it's been split into more pieces. So they need to remain equivalent. So that's why whatever I multiply the numerator by, I multiply the denominator by if I'm just finding an equivalent fraction. So 2 times 4 is 8. And then I go to the other fraction. And what have I multiplied 4 by to get to 12? I've multiplied it by 3. So then I'm going to multiply each part of this fraction by 3. 1 times 3 is 3, and 4 times 3 is 12. I've already done that. So now that they are both have the same denominator, they've both been cut into the same amount of pieces, I can just subtract them. So 8/12 minus 3/12 would be 5/12. The key thing is you subtract the numerator, but the denominator stays the same. Like if I said I had a square pizza and I ate 1 quarter, so I started out with 4 quarters of pizza and then I ate 1 quarter of the pizza, I'd be left with 3 out of 4 slices of the pizza. Okay, so that's why the denominator stays the same and the numerator changes. Okay, so here I'm told that Sean works for a company and his normal rate of pay is £12 per hour. So his normal pay is £12 per hour. When Sean works more than 8 hours a day, he is paid overtime for each hour he works more than 8 hours. So overtime is basically if you've worked more than your shift or more than you should, you get paid extra. Sometimes it's double, sometimes it's triple, sometimes it's just a little bit more. So Sean's rate of overtime pay per hour is 1¼ times his normal rate of pay per hour. On Monday, Sean worked for 10 hours. Work out the total amount of money Sean earned on Monday. So his normal pay is 8 hours. So we know that he worked 8 hours at his normal rate of pay, which is £12. So we do 8 hours times by £12 to work out how much he got for there. And then because he's worked in total for 10 hours, 10 take away 8 is 2. So we know that he's worked out 2 hours of overtime. Now the tricky bit is that we need to work out 1¼ of his normal rate of pay. So 1¼ to write it as an improper fraction is probably going to be the easiest thing that we can do. So to write an improper, it's already as an improper fraction, sorry, it's currently a mixed number, we want to turn it into an improper fraction. So to do that, what we do is we do 4 times 1, so the denominator times by the full number, 4 times 1 plus the numerator. So that would be 5/4. And the reason I do that is 1¼ technically what it means is I've got things split into quarters and I've got 1 full thing. So technically I've got 4 quarters here and then I've got an extra quarter. So that's why in total it's 5/4. So 1¼ as an improper fraction is 5/4. And then I need to work out 5/4 of 12. Now, whenever you see the word of in maths, it tends to mean multiply. So I'm going to do 5/4 times by 12, and to turn any number, regardless of how big it is, into a fraction, you just write it as over 1, because 12 divided by 1 is 1, but it makes life a little bit simpler when we're multiplying fractions. So now we multiply these together. 5 times 12. So remember, we could do the doubling and the halving method if we wanted to. So 5 times 12, I could double this to turn it into 10 and halve this to turn it into 6. So that becomes 10 times 6, which is 60. And then 4 times 1 is 4. So then I'm left with 60 divided by 4. So you could do the bus stop method, or with fractions, we can just simplify them if we feel confident doing that. So if I divide everything by 2, I'd be left with 30 divided by 2. And then I could divide by 2 again, which would be 15/1. So 60 divided by 4 is 15. Or you could have done the bus stop method, whichever way works best for you. So I know that his overtime pay is £15. And he's worked 2 hours of overtime. So we're going to just write that down. 2 hours times by 15. I can't remember if we worked out what 8 hours. either way if we haven't. So 8 times 12 I can do the doubling and halving method. So that could become, I'm trying to think of the easiest way, 4 times by 24, and then halve and double again, 2 times by 48, which is 96. So that would be £96, or you might already know your times tables very well and know that 8 times 12 is 96. And 2 times 15 is £30. So I want to work out the total, and total just means adding everything together. So 96 plus 30, 6 plus 0 is 6, 9 plus 3 is 12, so that would be £126. Okay, so in this question I'm being told that a farmer has 20 boxes of eggs and that there are 6 eggs in each box. So I need to write as a ratio the number of eggs in 2 boxes to the total number of eggs. Okay, so I know that there are 20 boxes of eggs, so 20 boxes, and in each of these boxes there are 6 eggs. So sometimes it helps to just draw things out so you can visualize it. So I've got 20 lots of 6. 20 times by 6, I can do the doubling and halving method again. So halve this, double that, 10 times 12, just add a 0 when you're timesing by 10, is 120. So I know that I have 120 eggs in total. And then I know that in one box, there are 6 eggs. So the number of eggs in 2 boxes, I'd have 2 lots of 6 eggs. So that would be 12. So 12 eggs in 2 boxes. Now I need to work out what the ratio, the number of eggs in 2 boxes, so in 2 boxes to the total number of eggs. Sometimes it helps when we're writing ratios to just write in words what it means above that. So the number of eggs in 2 boxes is 12. The total number of eggs is 120. And now I need to simplify this ratio. And just like with fractions, when you're simplifying a ratio, as long as you divide one side by the same thing you divide the other side by, the ratio will remain equivalent. So easiest thing to always divide by is 2. Generally, when you're dividing and simplifying, you want to try dividing by the prime numbers. So 2, 3, 5, 7. One of these is the best way to get to your answer the quickest. So let's divide by, I mean, you could also have spotted that they both divide by 12, but let's do it step by step. So divide it by 2, that would be 6 to 60. And then you could divide by 6, or you could divide by 2 again, which would be 3 to 30. And then you could divide by 3, so that would be 1 to 10. So however you got to that, so I kept on dividing by 2 and then dividing by 3. You could have divided by 12 to begin with. It doesn't matter, you're going to get to the same answer. Sometimes it just might be a few more steps. And simplest form essentially means when you can't divide your ratios any further. Okay, next we've got a sequence, a pattern that's made from circular tiles and square tiles. And I've been given the first 3 patterns in the sequence. So over here I've got 1, 2, 3, 4 circles. Over here I've got 1, 2, 3, 4, 5, 6, 7, 8 circles. Over here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 circles. So the pattern for circles goes 4, 8, 12. So I can see that each time I'm adding 4. Then let's look at the pattern for squares. I start with 1 square, then I get 1, 2, 3, 4. Then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's just to bear in mind so that you can think about what might be going on. The question says, how many square tiles are needed to make pattern number 6? So what you could do is you could draw it out. You could think to yourself, okay, I start with 1 square, and then what's happened is I started with this and then I add a square to the side and below and I fill it in to make a square. So similarly here, you start with this and you add a square to the side and below and you fill it in to make a square. Or hopefully you've recognized that these are the square numbers. So 1, 4, 9, you know, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So you may have recognised that, and therefore pattern number 6 would be 6 times 6, which is 36. If not, you can just draw it out. It will just take a little bit more time. And then it's saying how many circular tiles are needed to make pattern number 20. So this is where we need to look at the sequence that the circles are formed. So we know it's going 4, 8, 12. So essentially it's going up in the 4 times tables. So for the first pattern number, you need 4. For the second, it's 8. For the third, it's 12. So whatever the pattern number is, we're timesing it by 4 because it's the 4 times tables. So for pattern number 20, we need to do 20 times 4, which is 80. Okay, so next it tells me that when the pattern number is odd, an odd number of square tiles is needed to make the pattern. So here we've got an odd pattern number, and here. So when the pattern number is 1 square tile is needed. When the pattern number is 3, 9 square tiles are needed. And what can we do? We know from previously here, we know that the in terms of the tiles, that the pattern was going up in the square numbers. So for pattern number 1, we do 1 squared. For pattern number 3, we did 3 squared to figure out how many square tiles are needed. So when the pattern number is odd, we need to think about what happens when an odd number is squared. So an odd number times by an odd number, let's see what happens. Well, 1 times 1 is 1, 3 times 3 is 9, 5 times 5 is 25, 7 times 7 is 49. So whenever I multiply an odd number by another odd number, the result is always an odd number. So yes, Derek is right. Any odd number times by any other odd number, or any odd number times by itself, gives you an odd result. So here I'm being told that there are only 7 blue pens, 4 green pens and 6 red pens in a box, and that 1 pen is taken at random. Write down the probability that this pen is blue. So what I want to do for probability, I always need to know the total outcomes possible. So there are 7 blue pens, 4 green pens and 6 red pens in total. So 6 plus 4 is 10, plus 7 is 17 pens. So there's 17 pens in total. So the probability is going to be out of 17. And I know that 1 pen is taken at random, and I want to know that what the probability that this pen is blue would be. Well, there are 7 blue pens, so 7 out of the 17 pens are blue. Therefore, the probability would be 7 out of 17. So your denominator for probability is always the total amount of outcomes that you have, and the numerator is your given thing. So in this case is blue. Next we have a diagram showing a tree and a man. The man is of average height and the tree and the man are drawn to the same scale. So write down an estimate for the real height in meters of the man. So an average height of a man would be, how tall am I? I'm 1.64 meters. And I would say that most men are taller than me. So let's say, I don't know, anything between 1.8 to 2 meters would be the average height of a fully grown man. And this is an estimating question. So generally with estimating, you want to keep your answers nice roundable numbers. So I would say 2 meters. And then find an estimate for the real height in meters of the tree. So I know that the man is 2 meters roughly. How many lots of this? So 1, 2, 3, 4, 5. I would say that the tree is roughly 5 times the height of the man. So therefore the tree would be 5 times 2, which is 10 meters. And that's how I do that question. So when you're estimating, use your real world knowledge. You might know how tall you are. So how tall are you compared to the average man? And then use that, it's drawn to scale, so it means that whatever this height is, this is drawn in the same proportion. So if the tree is 5 times larger on the scale, then they'd be 5 times larger in real life. Now for this question, I'm being asked to draw a pie chart. And the key thing about pie charts is that they are a full circle. So all of the angles in a circle sum to 360 degrees. So therefore, all of the angles in a pie chart are always going to add up to 360 degrees. So I'm being told that there are 56 French students, 40 Spanish students, and 24 German students. So I need to split 360 into the total of what they are. So let's do that. So 56 plus 40 plus 24. 6 plus 4 is 10. 5 plus 4 is 9. 10, 11, 12. So 120. So I know the total number of students is 120. So to figure out how many degrees one student is, I know that there are 360 degrees in the whole pie chart, but I need to split that into 120 equal parts because there are 120 students. So I do 360 divided by 120. Now I would do it the fraction way, but you can do the division any way that you want. So it's in a fraction. So I know that first of all, I can divide by 10. So that would become 36 divided by 12. Then what could I do? I could divide by 3, I could divide by 12. So if I divided by 12, I know that that would become 36 divided by 12 is 3. So that would be 3 degrees. So one student represents 3 degrees on the pie chart. So if I had 56 students, I would have to do 56 times by 3. So 56 times by 3, you've got 3 times 6, which is 18. And 3 times 5 is 15, plus the 1 is 168 degrees. Then you've got 40 students times by 3, which would be 120 degrees. And then you've got 24 students times by 3, which would be 3 times 4 is 12, 3 times 2 is 6, add on the 1 is 72. And to double check that you've got all of this right, you know that all of the degrees should add up to make 360. So just to double check that all of your working is correct, you'd want to do 168 plus 120 plus 72, just to double check that they sum to 360. So 8 plus 2 is 10, 6 plus 2 is 8, 9, 9 plus 7 is 16, and 1 plus 1 plus 1 is 3. So you know that your angles are correct. Then what we do is we line up our protractor and we start to measure our angles. So 168 degrees, you'd line up your 0 over here. You'd read from 0, so you always start from 0 and you go to 168 degrees. So that would be over here. Then you label it, and that's 168 degrees. So use your protractor, line it up to 0 and go to where it says 168. Then we've got 120. So once again, you start with your protractor and we would get over here 120 degrees. And the final one, check that it makes 72 degrees. So you want to label your pie chart and you also want to say what each section is equal. So 168 degrees is for the French students. Over here we have our Spanish students. And here we have our German students. And that is how you do your pie chart. The key thing is remembering we do 360 divided by the total frequency, total amount of people or whatever it is, and that tells us how many degrees one item is worth. And from there we do that. So here we have to interpret the pie chart. We're told that Year 9 students from Lowry School were also asked to study one language to study, and the accurate pie chart shows information about their choices. So Shamina says that the pie chart shows that French was chosen by more Year 9 students at Lowry School than at Hull School. Well, over here we know that 56 students is represented by 168 degrees. Now over here we know that this half of the pie chart would be 180 degrees. So therefore all of this is more than 180 degrees. So we know it's more than 168 degrees, which is on the other side, on the other score. However, we haven't been given numbers. So for instance, it could be that there are only 20 students in total and that, let's say, 14 of them study French. So a greater proportion in Lowry School, study French, but we are not given numbers or values so we cannot know if she is correct. So without having actual values, we don't know. There could actually only be 20 students. There could be 2,000. Pie charts only show you the proportion, but without knowing the total, you can't tell. So next we've got a triangle and a rectangle. And I'm told that the area of the rectangle is 6 times the area of the triangle. And then I need to work out the width of the rectangle. So first of all, let's recap on the formulas. The area for a rectangle is just base times height, or width times height. And for a triangle, it's base times height divided by 2. So it's always really helpful to actually write out the formula so that you know what you're using. So I know that the area of the rectangle is 6 times the area of the triangle. So let's first of all work out what the area of the triangle is. So the area of the triangle is base 8 times by height 9 divided by 2. So 8 times 9 would be 72 divided by 2, which is 36. If you needed to, you could have done the bus stop method just to help you with that. So 2's into 7 go 3 times, remainder 1, 2's into 12 go 6. With any of these, if you can't do them mentally, just use the bus stop method. So the area of the triangle is 36 centimeters squared. And I know that the area of the rectangle is 6 times the area of the triangle. So I'm going to need to do 36 times by 6 to figure out what the area of the triangle is. So 6 times 6 is 36. And 6 times 3 is 18, plus 3 is 19, 20, 21. So the area of the rectangle is 216 centimeters squared. Now I know that 16 times by the width, so 16 times by the width equals 216, because that's how I work out area. So in order to work out what the width is, I'm going to need to do 216 divided by 16. And you can do this using the bus stop, or you can just divide. So let's just start by dividing by 2. 216 divided by 2. 2's into 2 go once, 2's into 1 go 0. 2's into 16 go 8, so that would be 108 divided by 8. Let's divide by 2 again. That would be 54 over 4. Let's divide by 2 again. That would be 27 divided by 2. And 27 divided by 2 gives me 13.5 centimetres. Okay, so in this question, I have been given a formula, V equals U plus AT, and I've been given 3 values for that formula. So when I've been given a formula, it's best to actually just think, what is the formula telling me? So V equals U plus AT. Now, whenever 2 numbers or letters or a number and a letter are next to each other in algebra, there's always like this invisible algebraic multiplication glue binding them together. So I could write that as V equals U plus A times by T. And I've just put it in brackets to show that I'm going to do that first, because if I think about BIDMAS, what do I do first? I do anything that is in brackets, then anything that is in indices, then any division or multiplication, and only after that do I do addition and subtraction. So I know that I'm going to have to do this multiplication first. Now, once I know what my formula is saying, I can substitute the values. So V equals U, which is 1, plus a, which is -3, times by t, which is a half. So I know I have to do this first because it's the multiplication. And again, when I'm multiplying fractions, if one of them is not a fraction, to turn it into a fraction, I just write it as over 1, and then I multiply as normal. So -3 times 1 is -3, 1 times 2 is 2. So that would be -3 over 2, which you can keep it as a fraction if you want, or it would be easier if we just turned it into a whole number, so -1.5. So v equals 1 plus -1.5. So when you've got a negative and a positive, two signs next to each other, adding a negative is the same as subtracting. So that would become v equals 1 minus 1.5, which is minus 0.5. So here I'm being told that 5 tins of soup have a total weight of 1,750 grams. So 5 tins equals 1,750 grams. 4 tins of soup and 3 packets of soup have a total weight of 1,490 grams. So I need to work out the total weight of 3 tins of soup and 2 packets of soup. Okay, so the first piece of information that I know for solid is that 5 tins of soup weigh 1,750 grams. So I could figure out how much 1 tin weighs by doing 1,750 divided by 5. So 5s into 1 don't go, so I carry the 1. 5s into 17 go 3, because 3 times 5 is 15, remainder 2. 5s into 25 go 5, 5s into 0 are 0. So 1 tin is 350 grams. So 4 tins and 3 packets, therefore, I could work out what 4 tins must be. So 4 tins, I would do 350 times by 4. So 4 times 0 is 0, 4 times 5 is 20, and 4 times 3 is 12. Add on the 2 is 1,400. So I know that 4 tins of soup weigh 1,400 grams. So 1,400 grams plus 3 packets weighs 1,490 grams. So to work out what 3 packets must weigh, I need to do 1,490. Let's get rid of some of this working. 1,490 take away 1,400. So that would be 0, 0, 9 take away 0 is 9, 4 take away 4 is 0, 1 take away 1 is 0. So 3 packets weigh 90 grams. Therefore, 1 packet, if I divide by 3, is 30 grams. So I know that 1 tin of soup, which I've previously worked out, is 350 grams, and 1 packet is 30 grams. So now I need to work out the total weight of 3 tins of soup and 2 packets of soup. So if 1 tin is 350, I do 350 times by 3 to work out what 3 tins would be. 3 times 0 is 0, 3 times 5 is 15, 3 times 3 is 9, add the 1 is 10. So that would be 1,050 plus 2 packets, so I do 30 times by 2, 2 times 0 is 0, 2 times 3 is 6. So I do 1,050 plus 60, which is, if I need to do it like this, then that's fine. 0 plus 0 is 0, 5 plus 6 is 11, 0 plus 1 is 1, and that leaves me with 1,110 grams. Next, I've got a circle question. So Bellina has a garden in the shape of a circle of radius 10 meters. He is going to cover the garden with grass seed to make a lawn. So the garden is in the shape of a circle, and all of this is his garden, and he's going to cover it in grass. Now, grass seed is sold in boxes. Each box will cover 46 meters squared of garden. Bellina wants to cover all of the garden with grass seed. So I need to work out an estimate for the number of boxes of grass seed Belina needs. Okay, so the word estimate is very important here because it means like round everything generally to one significant figure. So I know that the formula for the area of a circle is pi times by radius squared. So pi is normally 3.142 going on until infinity, but because it wants an estimate, I can just round it to one significant figure. So that would be 3 times by radius squared. So I know that the area of this garden is going to be 3 times by the radius is 10, so 3 times by 10 squared, which 10 squared is 10 times 10, which is 100. So therefore the area of the garden is roughly 300 meters squared. Now, because I'm estimating, I also round this. So I know that one box covers 46 meters squared, but because it's an estimate, I'm going to round to one significant figure. So that would be roughly approximately 50 meters squared. So to work out the number of boxes he needs, I would do 300 divided by 50. Now you can do it any way you want, but I just find division. If instead of doing it like this, I write it as a fraction because this line here means divide, and then you can just simplify it. So I can divide by 10 because we've both got zeros over there. So that would be 30 over 5, and then 30 divided by 5 is 6. So that would be 6 boxes. Now it says, is your estimate an underestimate or an overestimate? So let's think about it. I rounded 3.142, I rounded it down to 3, and I rounded 46, I rounded that up to 50. So generally, with a question like this, I would say that I rounded the area, the amount of grass seeds, up by quite a lot. So I would say that it is an underestimate, as the area is actually technically greater, so you could need more boxes. So here I've got another solve question, and remember, solve means work out the value of x, so get it in the form x equals. So I've got some brackets over here. So the first thing I want to do when I see brackets is to expand them, which means to multiply them out. So you're multiplying the number outside of the brackets by each term on the inside. So 4 times x is 4x, 4 times minus 5 is minus 20. So I'm left with 4x minus 20 equals 18. I then want to do the inverse operation to move everything from one side of the equation to the other. So I can put my finger over the x and see what else is on that side of the equation. It's a negative 20. So I'm going to add 20 because that then cancels out on this side. But whatever I do to one side of the equation, I have to do to the other to keep it balanced. So I'd be left with 4x equals 18 plus 20 is 38. Then I know that 4x actually means 4 times by x. So x is being multiplied by 4, and the inverse of multiplying by 4 is dividing by 4. So I divide by 4 so that that cancels out, and I'd be left with x equals 38 divided by 4. Now this is a fraction, so what I can do is just simplify it by first of all dividing by 2. So 38 divided by 2, 2's into 3 go once, remainder 1, 2's into 18 go 19. So that would be 19 divided by 2. Once again, let's do that. So 2's into 1 go 0, 2's into 19 go... my brain is frozen. Let's write out the 2 times tables. 2, 4, 6, 8, 10, 12, 14, 16, 18. So 2 times 9 is 18. And you're left with 1. 1 divided by 2 is 0.5. So that would be 9.5. So x is 9.5. It doesn't actually tell you to write it in its simplest form, so you could get away with writing it as 38 over 4. Okay, next you've got an inequality. So it says that minus 3 is less than t, which is less than or equal to 2. So if you see this little sign here, it would mean less than or equal to. That's why it kind of looks like an equal sign as well. So all the possible values of t, if I thought about it and I had a number line, -3 would be over here, then -2, -1, 0, 1, 2. So I know that my integer just means whole number, so it can't be a decimal. So I want to figure out what numbers it could be. Well, -3 is less than t, so it cannot be -3. It could, but it is in between -3 and 2. So it could be -2, it could be -1, 0, 1, and it could be 2 because it's less than or equal to 2. So the possible values would be -2, -1, 0, 1, and 2. Next, we've got a question with percentages. So Asmol is paid £1,500 a month. He's going to get a 3% increase in the amount of money he is paid. Work out how much money he will be paid per month after the increase. So what I need to do is work out what 3% of 1,500 is and add it on. So with percentages on the non-calculator, it's always helpful to just start by working out what 10% is. So 1,500 is equal to 100%. If I wanted to work out what 10% is, I would, or maybe I should switch these around. So 100% is equal to 1,500. To work out 10%, I would just divide by 10. The trick to work out 10% is always divide by 10. So 1,500 divided by 10 is 150. Now, if 10% is 150, to work out 1%, what do you divide 10 by to get to 1? You divide by 10 again. So 1% I divide by 10 would be 50. So I know that 1% is £15. I need to work out what 3% is. So what do I want to multiply 1 by to get to 3? I times by 3, and 15 times by 3 is 45. Or you could have done it like this. So 3 times 5 is 15, 3 times 1 is 3, plus the 1 is 4. So 3% I know is 45. His original salary was 1,500. He now gets £45 more, so that would be £1,545. So in this question, I'm told that the scatter graph shows the minimum temperature, the maximum temperature, and the number of hours of sunshine in 14 British towns on one day, and that one of the points is an outlier. Now, outlier is like thinking about which one is the odd one out. What piece of data doesn't fit with the general trend of everything else? So that would be this coordinate here, and I'm being asked to write down the coordinates. So that coordinate, if I look over here, that would be 10, and this coordinate would be 19. So I know that it would be 10 because it's halfway between 9 and 11, and this is halfway between 18 and 20. So I use the scale to determine where the coordinate is. Now next, I'm told for all of the other points, write down the type of correlation. So correlation can either be positive if the trend is going upwards, or it could be negative if the trend is going downwards. So this type of correlation, if I were to draw a line of best fit, that would be positive, because as one value goes up, so as one value goes up, so does the other. And that is how I can tell if it's positive or negative correlation. The next question says, on the same day in another British town, the maximum temperature was 16.4 degrees, and I need to estimate the number of hours of sunshine in this town on a day. Now, when you estimate, you absolutely must draw a line of best fit. Okay, so when you're estimating from a scatter graph, you need to draw a line of best fit, and that is essentially a straight line that has roughly the same amount of points above as below the line. It does not need to start from 0. It just needs to fit through as many of the points as possible. Oh, that's quite a thick one actually, because I've got, let's see if I can make it a bit thinner. Okay, so that would be my line of best fit. Now I use my line of best fit to work out what the question's asking me. So it's saying the maximum temperature was 16.4 degrees. So I use this to read it. So I know that, this would be 17. So between 16 and 17, there are 1, 2, 3, 4, 5 boxes. 1 divided by 5 is 0.2. So each tiny little square goes up by 0.2. So 16.2 and then 16.4. So I go across, so 16.4 would be over there. I go across to my line and then down to the x-axis. So I know that this value here would be 12. Once again, each little square moves up by 0.2, so that would be 12.246. So 12.6 hours. And then the final question says, a weatherman says temperatures are higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? So we can write a statement saying what is happening. So as the number of hours of sunshine increases, so my x-axis, as these values increase and gets larger, the maximum temperature also increases. The maximum temperature also increases. So yes, the weatherman is right. As there is a positive correlation. Okay, so here I'm being asked to express 56 as a product of its prime factors. Now, product means a multiplication. So what I want to do is work out what its prime factors are and write them as being multiplied as one another. So what I do is I start with 56 and then I try and find 2 of its factors. Now it's important to bear in mind what the prime numbers are. So the prime numbers are 2, 3, 5, 7, 11. Well, they're the first few prime numbers. So these are things that you should know off by heart. And ideally with something like this, you want to start with a prime number because then it just makes your life easier. So I could start with 2. So 56 is 2 times by something. So what I could do if I didn't know what that was, I would use bust up. So 2's into 5 go twice, remainder 1. 2's into 16 go 8. So 2 times by 28 gives me 56. Now, whenever I've got to a prime number, I circle it and I've extinguished that tree branch, because if I keep going, the only thing I could do is say that's 2 times 1, that's 2 times 1, and then it would go on forever. So when I get to a prime number, I circle it and extinguish that tree branch. And then I am just left with 28. And I have to find 2 numbers that multiply together to make 28. And ideally, one of them will be a prime number. So I could write 2 again. And 28 divided by 2, 2's into 2 go once, 2's into 8 go 4. So it'd be 2 times by 14. And I circle the 2 because it's a prime number. Then I think to myself, what 2 numbers multiply together to make 14? And that would be 2 times by 7. So both of these are prime numbers, so I circle them, and therefore 56 is 2 times by 2 times by 2 times by 7. So I could write that here as well. So when I'm doing this, all I'm doing is I'm finding factors of my original number. Anytime I get to a prime number, I circle it and I find factors of the number that's left until all of my little tree branches are extinguished, and then I just write them out being multiplied by one another, because product means multiplication. So next I've got multiplying decimals. So there's a little trick we can use here. So step 1, you want to write them as whole numbers. Okay, so what I want to do is ignore the decimals and just write them as whole numbers. So that would be 546 times by 43. Step 2, actually multiply them together. So I'm going to use the Napier's-Bones method just because I prefer this and I think there's less mistakes here. So I've got a 3-digit by a 2-digit number. So I'm going to create a 3 by 2 box. and then I'm going to write 546 over here and 43 over here. Now what I do is I split each box into two, and in the top part of the box I write my tens, and in the bottom part of the box I write my units. So if I was to write 16, I'd write 1 up here and 6 over here. So let's start by 6 times 4 is 24. 6 times 3 is 18. 4 times 4 is 16. 4 times 3 is 12. 5 times 4 is 20. And 5 times 3 is 15. So that's how I fill out my box. Now then, I just go along the diagonals. So this diagonal here, everything under that, it just amounts to 8. So I write 8 over here. My next diagonal, so what is in between this diagonal and this diagonal? 2 plus 1 plus 4, so that's 3 plus 4 is 7. Then I've got my next diagonal. So 6 plus 2 is 8, plus 1 is 9, plus 5 is 14. So when I've got more than like a 2-digit number, I carry the 1 into the next box. So then I'm left with 1 plus 1 plus 1, which is 3. And that doesn't count as 31. That just, actually, it might make more sense to write it in here. So that'll be 3, and then over here in this diagonal is just 2. So I know that 546 times by 43 equals 23,478. Now, when I do this, the reason I can use my little trick is because 54.6 times by 4.3, what have I done to turn that into whole numbers? So I've multiplied 54.6 by 10 to turn it into 546, and I've multiplied this by 10 as well. So in total, I've multiplied this calculation by 100 in order to turn it into this calculation. So then I need to then divide by 100 to figure out my final answer. So I know that 23,478, I'm going to have to divide by 100, or the little trick is, over here in my calculation, I've got 1 digit here and another digit here. So I've got 2 digits in total after the decimal point in my calculation. So for my final answer, I know I'm going to need to have 2 digits after the decimal point. So what I can do is just write that there, and then everything else goes over here. So my final answer would be 234.78. So in this question, I am told that the area of square ABCD is 10 centimeters squared. So how do you work out the area of a square? You do base times height. So I know that 3 plus x, which is the length of this square here, times by 3 plus x must equal 10 centimeters squared, because whatever my length is here times by my other length is going to give me the area. It just so happens that this is a slightly more complicated length. Now I need to show that x squared plus 6 equals 1. So there's a few ways I can do this. First of all, what I could do is I could work out the areas of the individual bits of the square. So over here, this area is going to be 3 times by 3, which is 9 centimeters squared. Then I could work out the area of this bit here. So that's x times by 3, because if that length here is 3, this length here would also be 3. So that would be 3x. Then here, that's x. That length here is also 3, so that would also be 3x. Or over here, I'd have x times by x, so that would be x squared. And then what I could do is write them all out. So I could say 9 plus 3x plus 3x plus x squared must equal to 10 centimeters squared, because that's what they've told me. So this is the area in here, and it must equal 10 centimeters squared. I could simplify that. So 3x plus 3x would be 6x. So 9 plus 6x plus x squared equals 10. And then I could rearrange it so that it's in order of powers. So x squared plus 6x plus 9 equals 10. All I've done is I've just moved them around so that they're in order. And now if I subtracted 9 from both sides, I'd be left with x squared plus 6x equals 1. So that's the first way that I could do it. The other way would have been the way we started off originally, which is by showing that the length would have been x plus 3, and therefore the other length would have been x plus 3 as well, and expanding my brackets. So I would have done x times by x is x squared, x times by 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. I would have then simplified it again, just like I did before, made it equal to 10 because that is what the area is, and rearranged it to get 1. So this is a slightly unusual question in that it's not just telling you to expand the brackets, it relies on you to realise that you could write this here as a length like that, or you could have even written it as 3 plus x, it doesn't matter. But recognising that this times by this would give you the area, and then rearranging it and simplifying. Okay, so here in this question, I'm told that the rectangular frame is made from 5 straight pieces of metal. So 1, 2, 3, 4, 5 pieces. All of these pieces make up the frame. And the weight of the metal is 1.5 kilograms per meter. Work out the total weight of the metal in the frame. So what I need to do is work out the total length of each piece of metal. So it's a rectangle, so some of these sides should be pretty easy. If this is 5 meters, then this side will also be 5 meters. And if this side here is 12 meters, then this side here is also going to be 12 meters. So that's pretty straightforward. But then I'm left with this length here. So this length here forms a right-angled triangle. And when I've got right-angled triangles, I can use two things, either Pythagoras or trigonometry. Now, Pythagoras is going to be what I want to use here. When I know the length of one side, so Pythagoras' theorem states that a squared plus b squared equals c squared. And the reason he's done that is because he discovered that if he worked out the area of the square formed by one of the sides and he added it to the area of the square formed by the other side, it makes up the area of the final side. So in this case, if this side is 5, the area would be 25. So if I did it numerically, it would be 5 squared plus 12 squared equals c squared. Here I am doing it visually simultaneously. So if this side is 12, 12 squared is 144. And he realised that for any right angle triangle in the world, if you add the area of the two smaller squares, so 144 plus 25, we could do it here. 5 plus 4 is 9, 4 plus 2 is 6, so that would be 169. So 25 plus 144 equals c squared, and therefore 169 equals c squared. Now when we get to that part, we know that the area is 169. So we know that the area of the large square, the one formed by the hypotenuse, is 169. So c squared equals 169, and therefore c is going to be the square root of 169. And this is where it's going to be really important that we know our square numbers up until 15. So the square of 169 is 13. So therefore, I finally know this length here. So I need to work out the total weight. So I need to add up the total of all of my lengths. So 12 plus 12, and then plus 5 plus 13. So 12 plus 12 gives me 24. 5 plus 5 is 10 plus 13. And then 24 plus 10 is 34. And 34 plus 13, I can do it like this. 4 plus 3 is 7. 3 plus 1 is 4. So that would be 47 meters. So the last part is I need to do 47 times by 1.5. Now there's a few ways that we could do this. So we could turn it into a fraction, or we could just do it multiplying. 1.5 means 1.5. So it just depends on what method you prefer using mentally. But let's just do multiplication. So we've got 47 times by 1.5. I'm going to times that calculation by 10 to become 47 times 15. I'm going to use the lattice method. So 47 times by 15. 7 times 1. Oh, let me draw the little thing. 7 times 1 is 0, 7. 7 times 5 is 35. 4 times 1 is 0, 4. And 4 times 5 is 20. Then I extend it. So under that diagonal, that's 5. Under this diagonal, 7 plus 3 is 10. So I carry the 1 into the next box. 4 plus 2 is 6, plus 1 is 7. So I know that 47 times 15 is 705. Now, because I multiplied my calculation by 10 in order to turn it into whole numbers, I'm going to have to now divide it by 10, so that 47 times by 1.5 becomes 70.5. Remember the little trick, in my calculation there was 1 digit after the decimal point, so in my answer that's going to have to be the case as well. So the total weight is 70.5 kilograms. For the next question, I'm being told that the equation of the line L1 is 3x minus 2. Now every line can be written in the equation y equals mx plus c, where m just represents the gradient and c represents the y-intercept. So whenever you've got an equation of a line, always rearrange it so it's in the form y equals something x plus something, and then you can compare it. And parallel lines, the key thing to know is that parallel lines have the same gradient. So that's how you can tell if they are parallel. So we know for our first line that y equals 3x minus 2. So the gradient is always the coefficient of x, which means the number in front of, like attached to the x. So the gradient for L1, the gradient is 3. Let's get rid of some working. Okay, so for the first line, the gradient is 3. Now what I need to do is work with a slightly trickier line, which is 3y minus 9x plus 5 equals 0. So what I want to do is rearrange this so that it's in the form y equals. So what I want to do is move everything from one side to the other. So let's start by moving 5 first. So 5 minus 5 cancels, that's why I always do the inverse. So 3y minus 9x equals minus 5. Then I can just move all of the x's, so plus 9x, and that would cancel. So that would be 3y equals 9x minus 5. And then what I would have to do is I would have to divide by 3, because this 3y means 3 times y. So I'd be left with y equals 9 divided by 3 is 3x minus 5 over 3. So for L2, the gradient is also 3. Therefore, the lines are parallel because, and I would write out, parallel lines have the same gradient. Okay, so in this question, I'm told that ABCD is a parallelogram and that the diagonals of the parallelogram intersect at O. So I know that OA, so this path here is A, and OB equals B. So I need to find, in terms of B, the vector DB. So when you've got a parallelogram, what that means is that each of your paths that are parallel to each other will be equal. So if the diagonals intersect, the thing that we need to know about parallelograms is that diagonals, when they intersect, that is the midpoint of the line, so that they intersect at the midpoint of the line. So therefore, if this root here is A, this root here is also going to be A. And similarly, if this root here is B, this root here would also be B. So the vector DB I would be going from D to O, which is B, and from O to B, which is B. So that would be 2B. Then I need to find, in terms of A and B, the vector AB. So let's have a look. How do I get from A to B? I go along this route. So with vectors, you can only go along an established route. So I'm going to have to go along here, and I'm reversing the direction. So if this direction is A, then when I reverse the direction, it's going to be negative A. So I do negative A plus B. So that'd be negative A plus B. And the final part, it says the vector AD. So this would be this route here. So how can I go along this route here? Well, I could go along A, so it would be negative A because I've reversed the direction. Along A again, so that would be negative 2A. And then along this route here, so CD, so I know that AB is minus A plus B. So therefore, CD, which is the reverse direction, would be A minus B, because I reverse everything, it's the negative. So that would be plus A minus B. So minus 2A plus A is minus A, and then I'm left with minus A minus B. And that's how I do that question. But I think this has actually been taken out of the curriculum, so don't worry too much about this. So thank you very much for watching. Hopefully that was helpful. And if there are any questions that you didn't quite get, just leave a comment and I can signpost you to a video that explains it in more depth.